Next presentation is about AI machine learning. Next presenter is Dr. Kenneth Lim from National Institute of Education in Singapore. The title of the presentation is Pedagogical Applications of Data Science and AI in the teaching and learning of the humanities. Please welcome him.
Thank you, Dr. Lee and colleagues and friends. I appreciate the opportunity to share my work with you. I'll just start sharing the screen. So I'm also grateful to the hosts at SNU, and I'm also grateful to Prof. Kwan for his earlier framing of the conversation. I'll try to build on some of Prof. Kwan's concepts, and just as he ended off with sharing some examples of AI in the curriculum, in the few minutes that we have today, I will try to share with you three further examples of work that my team and I have been involved in over the past year. So it's just going to be very touch and go, just so that you have a flavor of what some of the possibilities. Okay, so I'm going to try and minimize my screen here. Okay, so the three examples that I'm sharing with you today as a research scientist at the National Institute of Education in Singapore are the following. Actually, not all of them are directly to do with the humanities, because as the months elapsed between the invitation to speak and October 2021, I was able to conceptualize and execute further examples with my students. So firstly, we'll talk about an example with at the intersection of the Internet of Things, wearables, and microclimate, and then we'll move on to an example that a student teacher of mine came up with in history, and then we will end with an example which is more from STEM or STEAM with regards to investigating science in a real-life ecosystem. So first off, we will do the following example, which we call successful prediction of physiological stress from environmental factors. So as part of my work at the National Institute of Education, I mentor some high school students and junior high students, and here is a pair of the students whom I mentor, and together over the past year they have conceptualized of their own design. So in terms of Prof. Kwan's framing, this is AI as learner. AI as learner, right? That's how Prof. Kwan conceptualized it. Yes. AI empowered learner as leader. Yes, to use Prof. Kwan's framing. So this is the learner as the leader, and not the learner as the recipient. So what they have done is they have led by using the Internet of Things in terms of wearables, which they wear every day, and they've built them with everyday objects from the supermarket, as you can see here. And essentially, these are some of the microclimate variables that they have are measuring, and this is just a simple routine diagram which you'd be quite easily to understand. They wear the data around they wear the sensors around them, and then the data gets fed to the cloud, and then off to whatever. And what they've done is So this is just one example. I'm not going to present the results because that would not be fair to them, but I just want to give you a representation of what they've done today. So what they've done is they've taken some of these variables, and they initially wanted to just do a correlation of microclimate, namely things like the variables that you can see across the columns there, sound, infrared, temperature, humidity, and so on and so forth, and how they correlated with physiological factors from which they're such as those inputs from either wearables such as smartwatch or similar. So they've correlated it, and then after that, because the data set was quite large, so they were able to actually, as you can see here, they were able to actually come up with a predictive model using regression. And then they went on to do some more prediction from the data set using random forest. And this is, as I said, I'm not going to give you the results. The intent of these slides is not to give you the results, but just to give you an idea of the learning process that the students themselves engineered. So this was an entirely self-directed project because it was a internship, a year-long internship under my supervision. So considering, as you can see, if you remember, the students were only about 15 years old. They are basically doing university level mathematics, which is very impressive. And what they've recently gone on to do is they've, if you remember, the two parametric inputs would be physiological data and microclimate data. More recently, they have gone on to electroencephalogram, which is EEG, and they have fabricated using everyday parts like tape, as you can see, their own EEG kit, which they have been using, and their intention is to see how neurological data, physiological data, and microclimate data, what kind of interactions these have with respect to student stress levels, and given whatever microclimate conditions are existing in their school and at their hostel, at the dormitory. Yeah. So that's one project which these students have been doing, and you can see that around their waist they have been wearing their sensors. Okay, so now we move quickly on to the second project, which is this time it was not done by high school. It was not done by junior high students. It was actually done by a teacher in training. The university which I work at is a teacher education institute. It's because Singapore is so small, it's the only teacher education institute in Singapore. So so we basically conduct pre-service education programs for all the teachers in Singapore before they enter the school system. And one of these students who's training to be a history teacher, she came up with this idea of her own, again under an internship with me, and as a part of her general elective at the university. So what she did was she took, because she's training to be a history teacher, she took historical data of the port of Singapore. Singapore is a port. So what she did was she took data from shipping routes from the 18th and 19th century, and she put them into R, so that she could she basically was trying to investigate what kind of relationships would emerge from her analysis that prior historical analysis, not using the more up-to-date and contemporary digital humanities approaches, may have missed. So as the third bullet point there says, since the data set is large and hard to read, she was hoping that the data could be simplified for quicker understanding. So, and the fourth bullet point says this information may not be so obvious from just looking at the data sets alone. And thus she came up with map similar to this, showing the point of origin and of the ships, as well as the freight, the types of cargo, and how they evolved over time across the 200 years from the 18th and 19th century, as different traders and companies brought cargo to Singapore, as well as exported cargo out of Singapore. So potential uses of this project in the history curriculum, which I like very much because history is not really a subject that is readily associated with data science and artificial intelligence, and often the narrative gets taken over by STEM, is that it helps to get students interested in causes for the changes that took place over time. It helps students learn how data can be processed and utilized. And again, going back to Prof. Kwan's framing, this goes back to perhaps not so much learner as leader, but learner as collaborator, and definitely not learner as merely a recipient, as well as it builds increased relatability among the students to their present day environment. So in other words, based on the data, it reveals how globalized the world already was during the 18th and 19th century, similar to our present day world. So that is our second project. And finally, the last project I'd like to share is again done by two high school students, which I'm mentoring over the past 2 years. And this year, what they have come up with is they've been looking at a real life ecosystem and trying to understand the dynamics within the ecosystem. I'll do so by showing you some pictures. So basically, this first set of pictures is taken from a regular school in Singapore. This is a state-funded school. It is by no means special in any way in terms of its funding. So it has regular intake of students from around its local catchment area in Singapore. And traditionally, as you can see from the left, the traditional approach by the teachers has been to divide the class into groups, and the class goes around the school to collect microclimate data and just to basically observe the environment and to see what kinds of interesting things might occur to them. So along the way, one group of students, our students noticed that the fish pond that this school has was pretty interesting in that the fish tended to gather only at one end of the pond and not at the other end of the pond. So you can see that the pond is an S shape. It's shaped like an S with two ends connected by a narrow strip, and the fish tend to be gathering at one end of the pond, not at the other. So my student interns and my team member thought that this would be a good, interesting question to investigate. So what they did was they fabricated using, again, as far as possible, using everyday parts. And you can see that the workmanship here is very amateurish, but it is good that it's amateurish because it shows that I'm trying to emphasize that these are all student-initiated projects, learner as leader. So they basically came up with a camera connected to a microcontroller, which they put into which they attempted to make the housing as waterproof as possible using the black thing. And the things sticking out of the housing are the water quality sensors. So in addition to learning how to design and engineer such a housing and enclosure, and in addition to learning how to code the controller, they also had to learn chemistry because they had to learn how to calibrate with chemical pH solutions the water quality sensors so that they would be accurate in their readings. And this next set of photographs shows quite clearly the iteration of the housing from an everyday pipe bought from a plumbing store. This is actually a toilet pipe, which they then made their own housing for the camera, and then they put stuff on it, which is the fourth photograph. And after that, because we found that the waterproofing attempts were still not very good, the water was getting in because we did not know how to waterproof something like that properly. So what we did was we went to a vocational training institute in Singapore, and they helped us to make it a little bit more professional. And you can see that the last photograph on the right is the same product as the fourth photograph, but it's just neater and more because it has been helped by the Vocational Training Institute. So just two more slides. So what we after that, what they did was they tried to the next thing to do was to train the computer vision, and to do that they put the iPhone into the pond, and they needed to think about holding the iPhone upright because it kept getting improperly weighted. So they experimented with putting rocks to change the center of gravity in the box, and finally, so here you can see that they had to. So here basically what I'm trying to say is they had to learn about. If you remember the earlier slides, they learned about chemistry. If you remember earlier slides, they learned about design. If you remember earlier slides, they learned about coding. And here they are learning about physics because they are learning about how center of gravity and density vary. So I like this project very much because it brings together very clearly, and basically the whole context of this is the biology ecosystem. So it brings together very clearly all three sciences of STEM, plus the engineering, plus the mathematics, and yeah, and it's a student-initiated project. So with that, I would just like to stop my sharing and thank everyone for their time.
Okay, thank you. Thank you for your presentation.
감사합니다.
It was very, it was very impressive opening a topic for AI education pathway, and it was also very educational to show how to physiological and scientific data connect to the student learning and teachers teaching. So I hope lots of questions and discussions come from this topic. Thank you.